Hello everyone, welcome to the class of Econometrics 2. This is Econ 333. My name is Yasser Saeed and today we are going to study Granger Causality Test and Sims Causality Test. So let us start. In our earlier discussion on vector auto regressive models, we discussed that one of the good features of VAR model is that they allow us to test for the direction of causality. Causality in econometrics is somewhat different for different concept than we use in our day-to-day life. It actually refers to the ability of one variable to predict another variable. For example, if we have two variables, one we call yt and the other we call xt. Causality actually means how much of the changes in x can predict a change in y. Now, when we talk about vector autoregressive model, we may have a bicausality. Causality is not determined by theory, rather than we test it in our models. For example, we have the variable ytxt and we have also the lag value of yt and xt. So we write the lag values as yt minus 1, yt minus 2, y t minus 3 and so on. Similarly, we have lag value of xt as well, which is xt minus 1, xt minus 2, x t minus 3, and we may have many more lag terms of xt. Now yt may be affected by changes in xt, also changes in the lag value of xt, and changes in its own lag value. All of these three can affect yt. Similarly, xt can also be affected by all these variables. Let me rewrite it. Yt minus 1, yt minus 2, yt minus 3. Similarly, we take xt and xt minus 1, xt minus 2, xt minus 3. Yt can affect changes in xt. Similarly, the lag values of y can also affect xt, and the lag value of xt in itself can cause changes in xt. We may write this equation, but for Granger causality test, there are two causality tests that we will study here. For Granger causality test, we ignore xt, such as here we ignore xt, and for this purpose we ignore yt, rather than we only predict yt with the lag values of yt and xt. Here these will predict the changes in yt, and in our next case these two lag values will predict the changes in xt. So we can write the equation, the basic equation for our model, and that is yt is equal to a1 plus summation I from 1 up to n beta I x t minus I. So all the lag values of xt are represented in this single you can say summation, and then we have all the lag values of y which are from 1 up to, we have already utilized n, so we write m over here, and instead of beta now we have gamma as the coefficient for all the lag values of y, and this is yt minus j plus e1t. E1 because this is our first error term, E2 will represent our second error term. Yt is our in this scenario dependent variable which depends on all the lag value of xt minus I, and I is the number of legs that we have taken. If we have taken 3 legs, xt minus 1, x2 minus 2 and xt minus 3. Similarly, gamma I coefficient of y with its lag value up to j. J may have, if we have 4, j equal to 4, then yt minus 1, yt minus 2, yt minus 3 and yt minus 4. So that is how we can expand the equation. It was for x. Here we have written this equation for y. We call it equation number 1. We also write equation for xt, and xt has an identical equation. We just rename the variables plus a2 plus summation I is equal to 1 to n. Beta I has already been taken, so we write theta I and xt minus I plus summation j from 1 up till m. Gamma I has been taken, so let's take sigma j. Gamma j has been taken, sorry. So this is sigma j y t minus j plus e2, our second error term, and we have the time t factor. So this is basically our equation number 2. Now 4 cases are possible. Let me explain these 4 cases. The first case is the lagged x term in equation 1 may be statistically different from 0 as a group, and the lag y term in equation 2 may not statistically be different from 0. Let me show you in the equation. In the first equation, all the beta i's as a group may be different from 0, means that is not equal to 0, whereas the sigma j in the second equation as a group is equals 0. If that is equal 0 means y does not cause xt, but here it is not equals to 0, so xt is causing yt. So what do we deduct from the first case is that in this case x causes y. X has impact on y, or we may say we can predict changes in y with the variable x. Then we have the second case where the lagged y term in equation 2 may be statistically different from 0. Here this is statistically different from 0, it is not equal to 0, but as a group the lag y term in equation may not be statistically different from 0. See, this may not be statistically different from 0. So what does this mean? If it is equal to 0, then xt has no impact on yt, but yt has impact on xt. In this case, y causes x. Then we have a third scenario. Both x and y terms are statistically different from 0. Means beta I is also not equal to 0 and sigma I is also not equal to 0. In this case, xt causes y and yt causes xt. So both x and y can cause each other. And then we have a fourth scenario where both x and y terms are statistically not different from 0, means they are near to 0 or statistically equals 0. So xt has no impact on yt and yt has no impact on xt. In this scenario, there is no causation. Neither x causes y nor y causes x. There is no relationship established in such type of situation. So these are the four possible cases that we can get in the vector autoregression causality test, in the Granger causality test. So what are the steps involved in the Granger causality test? Let us discuss the steps. The first step in testing the Granger causality test is what we do is that we regress the yt on lagged terms of y, that is yt is equal to alpha 1 plus summation I is equal to 1 to m gamma I y t minus I plus e 1t. So this is our equation, and we regress the equation and we obtained the residual sum of square from this equation. We obtain residual sum of square. Then in the next step, okay, we call this residual sum of square the restricted one. We have restriction, we have remove all the other variables. In step 2, what we do, we again regress yt on lagged y, and in addition to this, now we also regress it on the lag terms of x. Lag terms of x. Our equation in this case, yt is equal to a1 plus summation and j is equal to 1 up till n beta I x t minus j plus summation I is equal to 1. The term that we have already used for regressing y terms of lag, so we rewrite that portion gamma I yt minus I plus e1t. And after regressing, we again obtain RSS, residual sum of square, and we call this residual sum of square the unrestricted, RSSU, unrestricted residual sum of square. Now we set the null hypothesis in step 3. Our null hypothesis is H naught summation j is equal to 1 to n b. Our null hypothesis summation beta j equals 0, and if it equals to 0, then it means that xt does not cause yt. Our alternate hypothesis h1 is summation and all the same elements summation beta I not equals 0. This is our main hypothesis, that the null hypothesis that beta I will equal to 0. If this is equal to 0, then what does this basically means? If beta I equals 0, this entire term will equal to 0. We are left with yt a1 plus exactly the same equation that we have written here. Let's say if this is equation 3, then our equation 4 and equation 3 will be identical. Both will be same. There will be no difference between the two. So what we have done, we have obtained the residual sum of square. If both equations are similar, then the residual sum of square of both equation will also be identical, and there will be no difference between the two. But if the residual sum of square is not identical, then in that case it means the two equations are not identical, and if the two equations are not identical, beta I will not equal to 0, and in that case xt will be causing yt, xt minus the lag terms will be causing yt. So in step 4 we write our basic equation. Here is our step 4. What we do, we calculate the F statistic, calculate F statistic, and our F statistic can be calculated as F equals residual sum of square of restricted minus residual sum of square unrestricted divided by m, and this whole divided by residual sum of square unrestricted along with the degree of freedom. So this is what I was talking about, the difference between the two residual square. If there is a difference between the two residual square, we will get a significant f value, and then that will mean that x causes y. Otherwise, if there was no difference between the two residual sum of squares statistically, then in that case we may accept the null hypothesis. In step 5, if the computed value of the computed f value exceeds the f critical value, if f computed, let's say this is f computed, if this exceeds f critical, then what we will do, we will reject the null hypothesis, and this is our null hypothesis. beta j equals 0. So if this is true, then we reject H naught, otherwise we fail to reject H naught. These are all the steps required for Granger causality test. Let us describe one more thing here, that is the value of k. How we determine the value of k? It is actually calculated by adding m, n and 1, whereas we know that m is the leg length of the variable y, and n is the maximum leg length of the variable x. So if we have taken three leg lengths of y, that is yt minus 1, yt minus 2, yt minus 3, then we will write 3 and then add it to the leg lengths of x variable. If we have taken two legs of x, so we add it 2 and then finally 1, so we will get k equal to 6. So this is the entire process for calculating the Granger causality test. The next thing is the Sims causality test. So let us discuss Sims causality test that he devised in 1980. Basically, Sims causality test is identical to the Granger causality test, but it has a slight difference, and we will discuss about that difference here. But first let us write the equation for the basic test. We have our variable yt, which equals a1 plus summation beta I x t minus I, and the value of I is from 1 up to n, plus summation gamma j and y t minus j, whereas the value of j is equal to 1 up to m, and here is the addition in the Sims causality test, that is the lead values of the variable x, and shortly I will describe why we need the lead value here. Row 1 to k and zeta row x t. Instead of writing minus, now we write plus over here. Plus represents that we are taking lead values instead of lag values, and E1t. We call this equation, let us call this equation 7, and we also write similar equation for x. Xt is equal to a2 plus summation I is equal to 1 to n, and we take theta I x t minus I plus summation j is equal to 1 up to m, and we write sigma j y t minus j plus summation rows value is from 1 to k, and instead of epsilon instead of zeta, now we write epsilon here with its value up to p, and y t plus p plus the error term So this becomes our equation 8. This is the Sims causality equation, the basic equation with addition of the lead value. Now, what does this equation mathematically means? Means that lag value of xt causes yt, the past value of x causes y, the past value of y causes y, and the future value of x causes y. So how is this possible? How the future value can cause the current value? This is logically not possible, but what does this mean, or why we have taken it? The basic idea is, if we found the value of zeta and epsilon positive, that means that the lead values have coefficient that is significantly different from 0. How do we interpret? Basically, it means that yt is actually causing xt. In such scenario, how we interpret it, since the future value cannot cause the present, and we found a relationship between these two variables, then it means the present value is causing the future value. So how we interpret this equation? If all these coefficients are significant, x causes yt, the lag value of y causes yt, and then yt causes xt. So this is the only difference between the Sim causality test and the Granger causality test. We just need to be careful with the interpretation of the lead values, where yt will be causing the lead value of x. Similarly, in the next equation, xt causes, the lag value of xt causes xt, the lag value of yt causes xt, and xt causes the future value, xt causes the future value of y. So hope you have understood this lecture. If you have any question or any problem, you can ask that in the comment section, and I hope I will answer those questions in the next lecture.